So we're talking about testing. We just talked about regression testing, which is making sure that things that used to work continue to work. And we're talking about how do you get better at testing? Is there a magic wand? There's not a magic wand. Closest I've found is this book, Developer Testing by Alex Tarlander. But even this book, like, you're not going to be any better at testing after you're done reading it. All it's going to do is help your learning curve on it. Because testing is like fundamentally about prediction. And it's very hard to predict something when you don't have a lot of experience with seeing what end results are possible, shouldn't happen, those kinds of things.
Kyle, so your testing can be in any language?
So that dovetails into our testing pyramid. So those of you who've seen this part before, talk me through it. What's the testing pyramid?
Well, the bottom's TypeScript.
Oh, for the trophy test? So more abstractly, it's not just TypeScript, it's anything that has...
Oh, type system.
Almost like, it's part of that. You're close, starts with an S.
Type safety.
Type fate?
Oh, static typing.
Static analysis. So static analysis is types. Those are one of them. So is linting. Anything that's just checking like your code as you're writing it. That's down at the bottom. What's above that? We have static analysis, something that starts with a U.
Unit testing.
There we go. Unit testing. There's two kinds of units. Like, people say, oh, unit is the fundamental like piece of your code, whatever that is. That's like, when I was learning this, that was such a fucking confusing answer. So I'll give you a more straightforward one if you'll forgive that it's not 100% accurate. Functions, objects. So if I pass these parameters or these arguments into a function, does it return this thing? It's one kind of unit test. The other kind of unit test is, if I call this method on this object, does its state change the way that I expect it to? Two kinds of tests. Both of those are unit tests. What's the next one?
Is it integration?
Yep. What's an integration test?
Is that going smaller or bigger?
It's bigger.
That's not app level, right?
Not quite. It could be. Doesn't have to be. Easiest definition is combination of units. If all these like functions and objects and stuff work okay on their own, do they work together?
So like components.
Components are like, in 2020, that's a pretty good go-to for an integration test. If I mount this component with this state and these props, does this thing show up? That's an integration test. It could also be app level if you take the server out of it. So if you go, assuming the backend works okay, does all the front end do the thing that I'm expecting it to do? That would also technically be an integration test. Okay, and then up here at the top is end-to-end. Same kind of thing, but with the back end. If I operate this app exactly the way that a user would, do I see the things and experience the things that I'm supposed to? That's an end-to-end test. So traditionally, these were drawn as a pyramid. Unit, integration, end-to-end. This guy named Kent Dodds, who's popular right now, came up with this idea of trophy testing, which I think reflects a much more accurate reality in 2020. That your static analysis tools are a pretty fundamental part. They replace the need for a lot of unit tests if you're using them correctly. They actually don't need that many unit tests. It used to be in the past. End-to-end tests are super fucking slow. Integration tests are or medium fucking slow. And unit tests are blazing fast. So you want a lot of unit tests, maybe not so much end-to-end tests. It's like increasingly kind of not being true anymore. So we unit test things that are good at being unit tested, like functions. And we integration test things that, that's where we spend most of our time. And every once in a while, really critical things in an app, we want to go the whole way through. So we do an end-to-end test. To give you an idea of tools, was another request. These, you have two options. Cypress and Selenium. There's a couple of also rans, like every once in a while you'll see Nightwatch. That was one that I was a fan of for a while. Nightmare was kind of popular for a while too. I did a talk on it once. Phantom. They all have like names like that because it's spooky to automate your browser like a ghost is using it.
That talk on your website?
Yep, yes it is. So those are like, these are kind of dead. Phantom is straight up discontinued. I haven't seen anybody use either of these two in like 5 years. It's all Cypress and Selenium nowadays, and Cypress is the clear winner. What Selenium has going for it is it can do multiple browsers, multiple versions. So you can set up like a matrix of browsers and versions and run your tests on all of them. Cypress isn't quite that robust. It just got like Firefox support this year. But Cypress is winning. It is by far the more pleasant testing experience in this kind of area. Also, you can do this kind of stuff with a whole fucking mess of tools. The most popular in JavaScript land for a while was Mocha, with a very handy library that is often paired with it called Chai. Both of those have recently fallen out of favor in JavaScript land for a tool called Jest. Like the brief history on that is that Mocha and Chai are awesome. They're also very fiddly, and like everybody has like a pet configuration for how to set them up right. And the end result is that it's harder to get into testing. And so Jest was like, nope, this is like Mocha and Chai, but it has all the plugins installed and it has everything set up right correctly out of the box. Just fucking use it. So those are JavaScript land. Ruby, RSpec seems to be the king. Outside of that, there's a whole bunch of these that fall under, that have like a similar layout to them. They make different ones for every language. called collectively XUnit. So JUnit is for Java, QUnit is for JavaScript, RUnit is for Ruby, and so on. But they're all otherwise kind of structured the same way. And then down here, static analysis, prettier, ESLint, TypeScript. Like all these are like JavaScripty kinds of things. Things like Java has mountains of static analysis stuff already. Like it's just part of the language. And yeah, that's your overview of the testing ecosystem. Ask me some questions about it.
Why did Mocha? It seemed like it was a pain in the ass to work with when you were working with it.
Yeah, it was a little bit. Some of it is that like I got really used to the Jest matchers, all the things that Chai does. Jest does them in a much better way, and I've gotten spoiled.
Is it hard to like transfer over to a different testing program?
Not really. So like, here, I'll show you. Okay, so this is a Mocha test. Has a describe block, has an it block. So this describes the thing that you're testing. In this case, it's like, it's a component. It, what's the test? What are the things that this should be able to do? Well, it should render past in videos. Well, it should, that's a stupid way to put that. It should allow a search term to be typed in. So what are you testing? How are you testing it? All right, how is that done in Cypress? Oops, that's Rails. Man, don't I have anything in here? Here, let me find some actual end-to-end tests then. This one. Oh shit, that's the BDD one. Hang on. It's another one. Oh, perfect. Any that aren't. Hey, what do you know? It's a describe block and an it block. Exact same thing. And then what about those Jest matchers? What am I using on this? Okay, so like this is also Mocha, just no Chai. You do these like assert.deep equals. Whereas over here I did expect to dot equal. What Jest does is looks like this. Expect to be truthy. So it doesn't have those like dots and stuff. It just has the entire thing like in one go. This is the level of difference that we're talking about though. Expect this to be truthy versus assert.deep equal versus dot contains versus expect to dot equal. That's the wild difference between these testing frameworks. Everything we've looked at so far also uses describes and its. The XUnit pattern doesn't use that, but like that's kind of what we're talking. There's like 2 different patterns in all of testing that people use. It's not the syntax. You can pick up the syntax of these things very quickly. I gave a talk on this like 2.equal thing. It's also my website. It was BDD syntax. And I'm irritated because I put a lot of effort into learning this syntax. Because it's a grammar. It has like a whole structure to it that you can combine and recombine in a bunch of cool ass ways. Just thought it was too confusing. And so they just made functions that are like 2deep_equal. And it's just the name of the function. I was like, oh, well, or we could make it easy. I'm so glad I fucking learned all of this shit. More questions?
So you said, so like in 2020 right now, we've got this trophy shape model for the overarching testing structure. Do you have an idea of what drives that that's relevant to us being programmers today?
Sure. A big part of the change from the pyramid to the trophy, some of it was just like people getting better at testing, developer testing becoming a more mature thing. A big part of it, though, was that end-to-end tests used to take forever and be like really brittle and really expensive, and they're just kind of not anymore. It's still slower. Like an end-to-end test is always going to be slower than any unit test. But they're also more valuable because if an end-to-end test works, it kind of doesn't matter which other tests don't work. Because this is describing like what the user does. If everything that a user does works, nothing else really matters. And so if it has that value and computers are getting faster and we're getting better tools for them, maybe we spend a little bit more time doing that. And so like I've seen Cypress take up more and more of the like testing mindset over the last couple of years. And then another thing that's kind of changed a little bit is you used to do things like, all right, so if I'm unit testing a function, what happens if I give it illegal values? So, all right, I have something that takes a number and doubles it. What happens if I give it a string? What happens if I give it a function? What kinds of errors can I make it throw? And so you test all these like weird edge cases on it. All right, well, if you had a type system, it wouldn't even compile if it was possible to do those things. So that's a whole category of unit tests that you don't need to write anymore. And also, if we have way more end-to-end and integration tests, again, unit tests don't quite matter as much. So where those come in handy is like, it was actually like kind of tricky to figure out how to write an end-to-end test for that debouncing thing for the search feature that we just did. But a lot easier to write a component level test for it. So basically what we did is you load up the component, you take over the clock, because like, all right, it's supposed to go every second. Don't have it go actually every second because then your test takes at a minimum a second to run. That gets out of control very quickly. If you have dozens, hundreds, thousands of tests, they can't all fucking take a second to run. So you use a fake clock for the system, and then you spy on this function. And then you do all the things that you would need to do, and then you move time forward a second, and then you expect that the function that you spied on got called one time.
So you can do tests on something as small as functions, but also as big as components.
Yeah, as big as applications.
Okay. And like, so for places that are very keen on like test-driven development,
Mhm.
will they expect you to test every function you write, or will they expect like where will they want to test on every level? Like how do they, what are their standards usually for that?
That's a great question. So, and here's a, like, I think it ties into this really well too. So we have a lot of tests for filtering, and we could have said like, all right, when I do this, these things show up. I mean, we have those tests already right now. The problem wasn't that like we weren't eventually getting the right result, is that it was slow as shit. And so the easiest way to test that would be to do it down at the function level, because we even had this working earlier today, but it was still getting called 4 times. And it turns out we were debouncing a thing that we should have throttled. And like the high level tests, these things, they don't know anything about the app. They don't know that this is a Vue app. They don't know that it has a Node backend. They're going in through the browser and operating it like a user, and then just testing that something shows up the way that a user would see it. To make sure that this thing only got called exactly once, we need to look at it at the function level. And so that's why we did it that way. Now, like, to more like directly answer your question, and this also kind of gets to the workflow thing that a bunch of you asked about. Okay, so let's say that this is a feature development loop. This is right here is defining a feature. What should this feature do? And maybe it's it should show a list of videos. If I go to the /videos page, I see a list of videos. All right. So then I write a test for that. If I open up a browser and navigate to that URL, can I find those 3 things in the DOM? Once that passes, I'm done. Okay, well, how can I make that pass? So then maybe you go down a level. You go, all right, so what if there's no server? Like, what if we just kind of take that out of the equation? So then this is kind of like also a fairly large loop. But you go, all right, I'm going to mock out any response that I get from a server. And in fact, if I go to a videos page, what happens is it's going to intercept any GET request to videos and just respond immediately with a list of videos. Just all of those. So I'm not also testing my server in that. I'm going to go like, all right, if the server works correctly, all right, well, I've taken some of the work out of that then. Made the problem smaller. Then next, I go, all right, so assuming that works, what if I make a page that's got hard-coded videos in it? So that's another loop. I write a test that says if I just hard code a bunch of videos on a page, Do they show up? They do. If I got style them, I got to do CSS, I got to do HTML elements, all that kind of shit. And then, all right, now can I pass those in dynamically? And do they still work? They do. Cool. So this idea of loops within loops within loops, that's the testing workflow. These have loops and these have loops. And that could go all the way from I'm automating a browser and I'm using it exactly the way that a user would to I'm passing this value into this function and I get this output. So it happens progressively at all those levels. This is called outside-in testing, or this is also called double loop testing. What does winning look like? What does winning this battle look like? What does winning this battle look like? What does winning this skirmish look like? And so you use the tests all the way through to like be your sanity check. And it kind of makes you define upfront what victory is. How will you know you're done? What's the thing you're hoping to see on the screen? What's the thing you're hoping comes back from the console log? You decide that first, and then you start writing code to make it pass. And that enables you to do shit like, all right, I hard-coded it here to make it go green. Now, as I make it dynamic, now as I put those in a variable, I just have to keep it green. That's so much easier than going red, 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 green. Give me the green right away, and then I just need to keep it green. It's so much fucking easier that way. Now, another thing that like was kind of implied in your question is you can't test everything. It's not you test every single function that you write. That's not a good use of your time either. Because what you inevitably end up doing, and this is the first thing you're going to fuck up in like your testing journey, is you're not going to test the outcome. You're going to test your implementation of it. That's not useful. You want to test that a feature works. You want to test that like some part of the application does something valuable. You don't want to test some micro component of that that's implied by something else. Because what happens is then you change your code and half your tests break. That's not useful either. I'll give you a good practical example of that from earlier today. The only thing that's being tested in that, where is it? Video search. The only thing that's actually being tested here is that filter IDs is called one time and one time only. That's this thing right here. I didn't also write a test for update search term. I didn't write one for update displayed IDs. I didn't write one for this updated or the updated or created hooks. Those are all part of that. But if the end-to-end test pass and this function only gets called one time, I don't give a shit about the rest of it. And in fact, I've already changed those other things a bunch of times, and I want the freedom to do that. The test shouldn't fail because I changed how I implemented a solution. It should only fail if the solution doesn't work anymore. More questions?
What you're saying right now reminds me a lot of the like the referential transparency and thin vertical slices.
Yep.
Is that, and so this has basically got the same benefits that both of those do.
This is part of thin vertical slices. So this big test here, that's your thin vertical slice. This is everything we need to make a feature work from a user's perspective. You can't do this style of testing with my backend's done, I designed my database, I've done everything but style my app. This doesn't work with that. It does work with, can students search for a video? And all the things that are involved with that. That's a thin and vertical slice. This is how we measure whether or not we have completed our thin vertical slice. I didn't put this in the trophy. It kind of goes across the entire thing. It's 3 kinds of testing like philosophies we could use that could still use all of these things. One is test last. Test last is, okay, cool, I'm done with my feature, I think. Let me write some automated tests for it. That's still better than nothing, because it still gives you all the benefits of regression testing. When you add a new feature, what things broke. That's called test last. Then there's TDD. TDD is, all right, before I write any code, I need a failing test. And when the test isn't failing, and I've cleaned up the code and it's still not failing, I'm done. That's TDD. Then there's a level past that. We could call this like TDD 2.0, called BDD. TDD is from the system's perspective. BDD is from the user's perspective. It's behavior-driven development. If a user uses the software in some way, do they get the desired result? BDD. And BDD is also like the hardest kind of testing. So like, I wouldn't start with it, but things like, let's see, E2E spec. This is a BDD spec. Hey, that looks like a thin vertical slice. Given that the students on the video page, when they search for some search term, only that many videos are shown, and only videos with that in the title are shown. For example, the following. So that's how the video stuff for the Firebase site works. What's fucking wild about this is it ties directly to code. Only this many videos are shown. Only that many videos are shown. And then I write like an actual implementation for the test. There's no programming in this. Your non-technical project manager could write this. Or if you gave this to a non-technical stakeholder, they could modify it. They come up with other examples of how the software should work. All right, but if I make it Rails, fuck, already breaking it. If I make it Rails, then I would expect that many to show up. They think of another example that's not happening right now. They can add that, and then that will be a failing test. that you can implement as a developer. So BDD is trying to bridge this like technical, non-technical divide so that these specs you're getting from your non-technical people become executable software. That's hardcore pro mode, but those are like 3 philosophies to testing. All right. Last thing I want to do, let's write a jest test. You can do this. I know we only got a couple minutes. We can write a jest test in a couple minutes. So I'd like you to pull up a terminal, go into an empty project, nothing in it. I want you to run npm init-y, like so. I want you to run npm install jest, like so. Man, I got to remember how this works. Hang on. Plural. Perfect. All right. So your folder should look like that right now. I want you to make a folder called tests. I want you to make a file called math.js. So now you should have an empty folder called tests. You have an empty JavaScript file called math.js. Now, I want you to make a file in that tests folder called tests, or in the test folder called math.spec.js. And if you did all this right, you should be able to run npx, not m, npx jest. And it should give you something that looks like this. Was anybody not able to get that to show up? Let us help you out. All right. So now we're going to go into this math.spec.js function that we wrote, or file that we made. And we're going to watch real carefully in the syntax for this. We're going to import, come on. There we go. Come on.
Take you back.
All right, am I back? All right, I
Kind of
see
back.
everybody.
Yeah.
I was there and you were there. All right, let me not run 6 of the most resource intensive things you can do on a computer at the same time. Closing some things, closing Slack. Closing that. Closing this. Okay, let's try this again. All right, so we're over here. I want you to import sum from ./math.js. Make sure you got the curlies in the right places and all that kind of shit. Oh shoot, I'm using Node. Never mind, scratch it. It's going to be const sum equals require .math.js. That's the one that we want. Sorry, oop, and with curlies. Competing module syntaxes. So I take it back. That's what it should look like. And then you are going to describe what you're testing. So you're going to describe sum. It's just a string. This could be fart. It can be whatever. The pound in front of it is just like in mod 1, when if it's a instance method, it starts with that. If it's a class method, it starts with that. For just functions and stuff, I think putting the little octothorpe in front of it helps. Describe is a function that takes 2 arguments. First one's that string. The second one is a function. If you're in mod 1, or sorry, if you're in mod 2, this is the exact same thing as doing a function that way. You can put functions in all kinds of fucked up places. All right. Describe sum. Well, it, same thing, takes in a label, adds 1 and 1, and takes another function. So your screen should look like my screen. So we expect that calling sum with 1 and 1 to be 2. And that's our first test. You could do that with a variable first if you wanted to. It's kind of common. Same thing. And if you try running npx jest now, it says sum is not a function. It's not. We imported something from an empty file. This is test-driven development. All you're doing is making the test runner get less mad at you. So the least that we could do to make that not so mad at us is to go into that math.js file and do make a function called sum. Doesn't do anything. And module.exports equals sum. Make sure you get the syntax on that right. It's a little fussy. You could put a comma after that one if you want to. Now if you npx jest, said sum was not a function. Now it says I expected 2, but I got undefined. All right. So the least that I could do to make that green just return 2. I got a passing test. Ah. All right. So why not that? I got to think of some more examples. So you make another example that says like it adds 2 and 2. Now if I run the tests, fuck. So you can keep doing this, and at some point, it becomes easier to just do it correctly. You have switch statements, you have all kinds of stupid things. But at some point, that becomes more complicated than the actual solution. So do the obvious answer. Run your tests, and they pass. Oh no, you get a new requirement from a stakeholder though. They want you to also be able to add 3 and 3 and 3. I didn't know, that wasn't in the spec. You didn't tell me it had to be able to take any number of arguments. And so we do that, we run our tests, and they get mad. So, all right, well, what can I do? I could use some like advanced JavaScript magic and take in all the numbers and then reduce them. Some number all right, so do that. I got passing tests again. Because not only did that one work, but all the previous ones worked too. That's test-driven development. And that is just enough testing syntax that you could probably play around the rest of the afternoon, at least the next hour. See if you can get the other math stuff to work. It's good test writing practice. Any last questions?
I'm just trying to figure out why my tests are still failing.
That's half the fun.
I don't know if I wrote something wrong. What was the part that you said was tricky with the syntax that can throw errors for you?
This.
Or module that experts equals. I think I got that right. Does it matter what kind of function you write? Does it matter if it's like a old school or new school JavaScript function?
Nope. By the way, this should look familiar. This is exactly how all your Learn Labs work. Anything else?
Sort of. Not so much on this, but could we make this like a series?
Sure. You talked me into it. I hate talking about testing so much. Cool. All right, I'm gonna go teach TS generics. Might see somebody there. Might just be me and Brian. All right. Bless y'all. Cheers.
Thanks, Kyle.